Hello, this is lesson 3-3, graphing quadratic equations or functions, same thing, and inequalities. Specifically today we're looking at standard form. Alright, and so we're going to take a look at what that means. We're still in Unit 3. Make sure you write the date. And our objective is to graph quadratic functions and inequalities written in standard form. Pause the video, make sure you get this stuff written down, and we're going to jump right in. So, quadratic function. A quadratic function is another type of function family. So this is different than absolute value. So we're in a whole new family of functions now. Quadratics create a U-shaped curve called a parabola. This is a key word here. Parabola is a U-shaped curve. Standard form of a quadratic function looks like this: ax squared plus bx plus c. Now there are some key terms here. This a term specifically, if a is positive, your u is going to open up. And it's going to look like this. If a is negative, your u is going to open down. Okay? Kind of like reflection. We know that if there's a negative out in front of everything, it's a reflection across the x-axis. Same thing applies with our parabolas. Okay, so again, if a is positive, your U-shape will open up. If a is negative, your U-shape will be upside down. Now there are some specific parts of a parabola. One key part of a parabola is called the axis of symmetry. So axis of symmetry. The axis of symmetry just divides a parabola into two equal parts. And it is a vertical line. Now the axis of symmetry is a key feature of a parabola. It's the key feature of a quadratic equation. And there is a formula for finding the axis of symmetry. And so we're going to write this down. Axis of symmetry formula is going to be our next key over here. Again, this is super important. This is something we have to memorize. We're going to use this a ton. So axis of symmetry formula, super important over here. X equals, so we said it's a vertical line, so it's going to be x equals negative b over 2a. Another key feature, a key part of a parabola is called the vertex. So we had a vertex of absolute value. We also have a vertex of parabolas. I'm going to put an arrow here just so I can organize this, because I'm going to utilize this blank space over here to define vertex. So your vertex, just like an absolute value, your vertex is a turning point. When the vertex is the lowest point, it is called a minimum. When the vertex is your highest point, it's called a maximum. So we're going to go ahead and we're going to graph the parent function of a quadratic, and we're going to label all of these things. So taking a look at the parent function. F of x equals x squared. Okay, so quadratics are always squared. So if we take a look at the parent function of this, all we're going to do is make a table of values, okay? So x and then f of x. All right. And we'll number these -3, -2, -1, 0, 1, 2, 3, just like we did with our absolute value function. And now if I plug this in, -3 squared. -3 squared is 9. If I plug in -2 squared, -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Notice that similar pattern that we saw with absolute value. Our numbers are going down, and then boom, this is our turning point. Our numbers start to go up. So again, your turning point is the same as your vertex. So let's go ahead and plot these. So -3, 9. 1, 2, 3, 4, 5, 6, 7, 8. I don't really have enough room, so I'm going to skip that one. -2, 4. So there. -1, 1. 0, 0. 1, 1. 2, 4. And then 3, 9 also doesn't fit. Now remember, this is a U shape. This is not a V shape anymore. Oops, that goes over there. Let me just take care of that point right there. Sorry guys. Okay, so it's a U shape, not a V shape. Remember, parabola is a U. Quadratic, think the U in quadratic, help you remember. Now, let's label the different points of this function. So our axis of symmetry, again, divides the parabola into two equal parts, and it's a vertical line. So if we take a look, our parabola is already drawn, and this line right here, our y-axis, actually would divide that into two equal parts. That would split our parabola into two equal parts. So this is our axis of symmetry. Our vertex, again, is our turning point. When it's the lowest point, it's a minimum, and when it's the highest point, it's a maximum. So we take a look here, this is our vertex, 0, 0. Is this the lowest point, or is this the highest point? Well, here it's the lowest point, and so for this example, our vertex is a minimum. We're going to take a look at how to graph other quadratic functions in standard form. So the steps to graphing quadratics in standard form. The first thing you want to do is to use the axis of symmetry formula to find the vertex. Our axis of symmetry formula is going to give us the x value of the vertex, and if we plug it back into our quadratic, we'll get the y value. So use the axis of symmetry formula to find the vertex. Second, we're going to create a table. Place the vertex in the middle row, just like we did with absolute value. And then number up and down. You want to complete the table, evaluate each value for x in the function. And then your last step, step 3, is to graph. Graph your table of values. Okay, so let's say we have f of x equals -3x squared. The first thing we want to do is use the axis of symmetry formula to find the vertex. The axis of symmetry, again, is going to give us the x value of the vertex. So our axis of symmetry formula is x equals -b over 2a. And so we're just going to plug those things in. Now remember, standard form, I'm going to write that up here so we don't forget, is ax squared plus bx plus c. Notice that in this function we only have our ax squared term. We don't have a bx, we don't have a c. So we'll just use 0 for those values. So there's no b term, so we're going to substitute in a 0. Now over 2a, so over 2 times, this is our a term right here, negative 3. And we're going to simplify that. Well, that would be 0 over negative 6, which is 0. This is the x value of the vertex. We're going to now make a table and place this value in the middle row. So making our table of values, we have x, and then we have f of x. Remember, f of x just represents our function. 0 is going to go in the middle row. So we're going to put 0 right here, and we're going to number up and down. So 1, 2, and then negative 1, negative 2. Next, we're just going to complete the table. So we're going to evaluate the function for each of these values for x. So negative 3 times negative 2 squared equals, and you can just use your calculator for this. It'll make it really quick for you. So negative 3 times negative 2 squared. And we get negative 12. And then I'm going to type in a negative 1, and I get negative 3. I'm going to type in a 0 now, and I get 0. Okay, type in a 1, so I'm just editing this. I'm going to put a 1 in there, and I get negative 3. Notice after our turning point here, our numbers are going to start to go follow that pattern again, and then I'm going to plug in a 2, negative 12. Okay, now I'm ready to graph. So step 3 is to graph. So taking a look here, I've got negative 2, comma, negative 12. Well, I don't have enough space on my coordinate plane to graph that, so I'm going to move to the next one. Negative 1, negative 3. 0, 0. Positive 1, negative 3. And then again, I don't have enough space to graph 2, negative 12. Now remember, this is a U shape, so I'm just going to make my U. All right, so some key features of this. Our axis of symmetry is x equals 0. We plug that in to find our vertex. So this is the vertex, our turning point. If we take a look at this graph, our vertex is going to be a maximum because it is the highest point. So vertex equals maximum. Now let's list the domain and range of this function. So if I list the domain, left to right, what do I notice on the left? We have an arrow, so that's negative infinity, comma, and then on the right, positive infinity. This will always be your domain for quadratics. Quadratics always have this same domain. So let's go ahead and write that down. Quadratics always have this domain. This is the domain for all quadratics. Now that is not true for the range. The range will change based on where your vertex is and based on whether your U shape is up or down. So again, range is bottom to top. So on the bottom, I see arrows pointing down. So we have negative infinity. And now what's my highest point? My highest point is 0. And I'm going to put a bracket because 0 is a part of this function. All right, so let's try this one. F of x equals x squared minus 6x plus 11. Step 1, use the axis of symmetry formula to find the vertex. All right, so we've got x equals negative b over 2a. Looking at this now, I have all three terms. So I have a, b, and c. Now looking, there is no number in front of x squared, so my a term is a positive 1. My b term is a negative 6, and my c term is a positive 11. So I'm just going to substitute negative b, so x equals negative, and then my b is negative 6. Okay, careful of those two negatives there. Over 2a, so 2 times 1, because there's not a number in front of x squared. And now I'm going to simplify this. 2 negatives makes a positive, so 6 over 2, and we get 3. So now, once I have my axis of symmetry, what do I do with it? Well, we're going to put it in the middle row of our table, and we're going to evaluate our function for each value in our table. And that's going to help us graph. So we have x, and then we have f of x. We're going to put 3 in the middle. Number up and down, so 3, 4, 5, and then 3, 2, 1. This table just needs to make sense numerically. And now we're going to plug this value into our function, each value, to figure out the output. So 1 squared minus 6 times 1 plus 11 equals. I'm going to let that calculator do the work for me. 1 squared minus 6 times 1 plus 11. Plus 11. And we get 6. Now at this point, I'm not going to rewrite everything. I'm just going to retype in my calculator and replace all the 1s with a 2. And we get 3. I'm going to evaluate now for the vertex. So plug in this axis of symmetry here, which is 3, to get the vertex, which is 2. And now since this is the vertex and the turning point, we can expect our values to turn and now follow the pattern back up. So 6, 3, 2. I'm expecting this to be a 3 and then a 6. So plug in a 4. And we get a 3. Plug in a 5. We should get a 6. And we get a 6. Okay. Now remembering that this value right here was the vertex. That's our turning point. So we're going to plot all these ordered pairs now. So 1, 6. 2, 3, 3, 2, 4, 3, and 5, 6. Draw your U shape. So taking a look at the vertex, is our vertex in this example a maximum or a minimum? So our vertex is a minimum this time because it is the lowest point. So a vertex is a minimum. That word says minimum. And now if I was to identify the domain and range, so domain, always and always for quadratics, negative to positive infinity, and for range, bottom to top. So our lowest point here is our vertex. The y value is a 2, so that's going to get a bracket. And then our highest points, well, arrows mean it continues on to infinity. Okay, there's one more example. We're going to take a look at inequalities. Again, our inequalities follow the same steps as just our regular equations, except we have our dashed line, solid line, and our shading that we have to worry about. So quadratic inequalities will be next. We're going to take a look at one example. So f of x is less than or equal to negative x squared plus 4x minus 1. All right, so this is A, this is B, this is C. Step 1, create your table of values. First, find the axis of symmetry and put that in your table. So x equals negative b over 2a. We're going to plug in negative b, which is, we do have a b term. Our b term is with x always. Negative 4 over 2a. So our a term, there's no number in front, but we do have a negative. So that's 2 times negative 1. So then we have negative 2 over negative 4 over negative 2, which is a positive 2. Okay, so that goes in the middle row of our table. So now we'll create our table of values, x and f of x. In the middle, we're going to place our positive 2. Then we're going to number up and down, so 3, 4, and then 1, 0. And we're going to plug each of these values into our function. So negative 0 squared plus 4 times 0 minus 1. And we get negative 1. Okay, then we're going to plug in the rest of our values here. So I'm going to use my calculator for that. We got negative 1 squared. Don't forget those parentheses. And notice here I put the negative outside the parentheses. Negative x squared plus 4 times 1 squared minus 1. We get 2. I'm going to type in a 2 and we get 3. Then I'm going to edit this and I'm going to type in a 3 and we get 2. So notice our vertex was our turning point. So now our numbers are going to climb back down. Type in a 4 now and I should expect to see a negative 1. But I want to just make sure. Negative 1. Perfect. Next, I'm going to graph this. Keeping in mind that's our vertex right there. I'm going to graph this and I'm going to consider that inequality symbol when I graph. And that's going to let me know if I should use a solid line or a dashed line and whether my shading is above or below. So if we take a look at this inequality symbol, that means this is a solid line and we're shading below. Alright, solid line, shade below. So I'm going to graph this by plotting all the points. So 0, negative 1, 1, 2, 2, 3, 3, 2, and 4, negative 1. Solid line. So I'm going to draw my U shape and I'm going to extend this all the way because I'm going to have to shade here. And then shade below just means below the function, which is everything underneath that U. If it was above, it'd be everything outside of the U. That's all for these notes, you guys. So please bring your questions with you to class tomorrow.